So we talk about average rate of change a lot without even really thinking of it. Anytime you talk about like how long it took you to get somewhere compared to the miles that you traveled, you're really talking about your average speed. So if you say, hey, we drove all the way to Florida in 10 hours, and say the trip was 700 miles, that's really your average speed or your average rate of change when you say that, because it's really 700 divided by 10. We also talk about growth rates of populations. We might talk about that in like percent per year. Average monthly rainfall, that's another common place where we see average rate of change. That's usually measured in inches per month. So the average rate of change of a quantity over a period of time is the amount of change divided by the time it takes. So back to my Florida example, we're doing the amount of change in the distance compared to the time. In general, the average rate of change of a function over an interval is the amount of change divided by the length of the interval. So here we've got a formula. It says to find our average rate of change if we're given a function on a closed interval. Closed just means that we have a definite starting point and a definite ending point. To find that average rate of change, all we have to do is do f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. And that's really the same thing as finding the slope of a line connecting 2 points. But you probably haven't found slope in this way before. It says find the average rate of change for each of the following. We have a function, f of x equals x squared plus 4. We're talking about the interval from 1 to 4. We want to find that average rate of change. Let me just explain what we're doing. Here's our function. We're talking about between this x value of 1 and this x value of 4. What's the average rate of change of that function over that interval? Well, what I'm really doing is finding 2 points. This point is when x is 4. This point is when x is 1. So to find the y values, we just plug it in. So this is going to be 20, and this is going to be 5. So then we're doing, to find that average rate of change, which we'll just abbreviate AROC, average rate of change, it's going to be 20 minus 5 over 4 minus 1. So 15 over 3 equals 5. See what we really did though? We really did this without thinking of it. We did, this is our x sub 1, this is our x sub 2. So we're doing f of this point, which is 20, minus f of this point, which is 5, and then all over this x minus that x. Okay? So this is like a visual way of doing it, or a graphing approach, and this is a more analytical approach. All right, let's look at number 2. On day 10, there are 200 bacteria in a petri dish. On day 15, there are 522 bacteria. We're supposed to find the average rate of change. Well, let's write this as an ordered pair. 10, 200, 15, 522. Days, number of bacteria. Days, number of bacteria. And so now we just find the slope, basically. So that average rate of change then is going to be 522 minus 200 over 15 minus 10. Watch how you can divide this, guys, pretty quickly. I'm going to do 5 goes into 32 6 times with 2 left over. 5 goes into 22 4 times with 2 left over, and I was dividing by 5. Don't grab a calculator for things like that. You don't need it. So 64, you couldn't do that? You didn't get that? Okay, I'll show you again with another example, but I'll do it one more time. So we have 64 and 2/5. Now what would be our units on this? All right, bacteria per day. So we'll just put bac per day. Let me do that quick division again. Okay, 423 divided by 6. Well, I'll show you anyway. This one's pretty easy. Okay, 42 divided by 6 is 7. We would have nothing left, but how many times does 6 go into 3? 0 times. How many do we have left over? So it's 70 and a half. Okay. One more. Let's see. Let's do a harder one. 522 divided by 3. Okay, what's 5 divided by 3? 1 with 2 left over, right? So now we have 22. So what's 22 divided by 3? 7. How many are left over? So we put a little 1 there. So what's 12 divided by 3? So it's 174. You can do that.
Can you do that with as many digits as possible?
Mm-hmm.
1,000?
Sure. Do you want me to?
No.
Do it.
What do you want to do? Divided by what? 8? Okay. So watch, guys. 13 divided by 8 is what? How many left over? Put a 5 up there. You have to be able to know how many's left over. What's 57 divided by 8? 7. How many left over? Exactly. 1. And then what's 16 divided by 8? 2. Yeah. You've never thought to divide like that? I always divide. Okay. All right. Another cool thing is multiplying. Let me show you how to multiply. Let's say you've got 17 times 4. That's 40 and 28, so that's 68.
Oh, yeah.
Okay, let's do a harder one. What's 18 times 7? That's 70 and 56, so it's 126. Do you know what I'm doing there? Instead of thinking of it as 56, write down the 6, carry the 5, I can't do that as quickly as I can think of it as 10 and 8. So I'm really doing 10 times 7 is 70, and then 56. I'm thinking of it that way. It goes faster, I promise. Try to change your brain to think that way, and you'll be much faster with everything. Okay, let's do this. So we have f of x equals 2 plus cosine x over 0 to pi. So this would be our x sub 1. This would be our x sub 2. Because that's our closed interval. So I hope you know what this looks like. Do you know what the cosine curve looks like? Yep. Alex says it. It's going like this. It goes forever and ever. But it's shifted up 2 units. So normally our cosine goes 1, 0, negative 1, 0, 1. But now it's going to go, what? 3. So this is the way it looks. It's been shifted up 2 units. And we're looking from 0 to pi. What's that average rate of change? What does it look like it is even? Looks like it's about negative 1, doesn't it? Let's see what it is exactly. Okay, so I would have to plug in our pi first of all. What's the cosine of pi? No, cosine of pi is the x value. Negative 1. So I'm going to do 2 plus negative 1. That's what I get for f of pi. And then f of 0, that's 1 right there. F of 0 right here. So plug that in. What's the cosine of 0? So 2 plus 1 is going to be 3. Okay, so then to find my slope, I have to do f of pi, which is 1, minus f of 0, which is 3, and then all over pi minus 0. And so that's negative 2 over pi. That's going to be our average rate of change. Remember how I said it's close to negative 1? Is negative 2 over pi close to negative 1? Kind of is, isn't it? Because it's about negative 2/3, so that's pretty close to negative 1. Okay, number 4. Find the equation of line through the points. What do we need to know first to find the equation of line? Slope. So to find our slope, let's do it quickly. 8 minus 5, 2 minus negative 3. 3/5 is our slope. In here, we're always going to put them in y equals mx plus b form, which is point slope formula. Which is slope-intercept formula. This is slope-intercept formula. That's the way we're always going to write it. You can choose either point. I'm going to choose this one because I don't have any negatives to deal with. So to find this now, I'm going to have to use my point slope formula. So y minus 8 equals m times x minus 2. Now let me show you this shortcut too, guys. So this is going to be y equals 3/5 x minus 6/5 plus 40/5. Let that sink in. Can you understand why I did that? I'm trying to just do it real quick in one step. So now I've got y equals 3/5 x plus 34/5. And I know that we all kind of hate to be rushed, but one of the biggest things to being successful in college level math is time. They don't give you extra time in college, and like a lot of people could do pretty well in calculus if they just had the time to figure it out. So like little tricks like that division and things like just getting that answer quickly, that's going to help you a lot. All right, let's take a look at number 5. Find the average rate of change over the interval from 0 to 12. Well, here's 0 and here's 12. First of all, is that a positive or negative average rate of change? It's positive. It's going uphill. Anybody know how we can do that? Do we know f of 0 and f of 12? Okay, McKenna, what's f of 0?
0.
What's f of 12? Okay, so we know our y's, don't we? Do we know the x's? Yep, 0 and 12, right? So to find our average rate of change, you guys figure it out. Tell me when you got it. Grace, what'd you get?
1/3.
1/3. Anybody else get 1/3? Yep, 1/3 is right. We have to do the difference in our y's is 4, the difference in our x's is 12, and so therefore that's going to be 1/3. Okay, that's all we're doing today. We have a worksheet for homework today.